Yes, hello. So I am CA Yogesh and we are doing standard 12th, chapter number 1, part 2, probability. Yes. In probability, there is a compulsory that you have to see all my lectures in a sequence. That means this is my lecture number 2 of the probability. You have to see the lecture number 1, then you have to jump to this lecture number 2. Yes, everything is available on YouTube, so you can see it, subscribe it, and pause and watch it. Okay, it is advisable and it is compulsory that you should have your book, pen, pencil, calculator with you, and you all are writing everything which I am teaching you. As I told you that there is an advantage of this virtual class also that you can pause, you can take your time and write it, and again you can play. Yes, you can watch it as many as time as you want. You can see it your convenience. Okay, so there are many good things also about this. Yes, last lecture we want to see what we have done. Uh, we have done many things in the last lecture. Uh, I told you about random experiment. Then I told you about sample space. We have done some illustration also, and we have started exercise 1.1 suppose some coin is thrown three times, and we have found the sample space also. Now we are moving ahead to the second question. A balanced dice with six sides and a balanced coin are tossed together. So this is number two question. What is the question? A balanced dice. It is dice with six sides and a balanced coin are together. So I can say dice and coin is tossed together. A dice and coin is together, and you need to find the sample space. How will you find it? For example, in coin there is a head. Then in dice there can be one. Same way, there is a head in coin. In dice there can be two. In same way, it can be head three, head four, head five, head six. Okay, I am tossing a coin and dice. So first I have assumed that in coin there is head. So in dice there can be one, there can be two, there can be three, there can be four, there can be five, there can be six. Now, what happens if there is tail in the coin? If there is a tail in the coin, if there is a tail in the coin, then there can be one in the dice. Same way, there can be two with the tail, there can be three, there can be four, there can be five, and there can be six. So, if a dice and coin is tossed together, there can be 12 outcomes. H1, H2, H3, H6, T1, T2, T3, T6. How can I get, sir, these number of outcomes? I told you that in dice there are six possibilities, and in coin there are two possibilities. So if I toss both together, there can be 12 possibilities. There can be 12 possibilities. Now, in third question, two persons are selected from five-person A, B, C, D, E. Now there is a word called selected. Now you have to remember that selection is altogether a different thing. Sir, what is this selection? I'll tell you what is this selection. Now I am going to explain you two different words. One is selection and one is arrangement. One is selection and one is arrangement. Okay. Now these are two different words, and you have to focus on the question that what is given. Uh, as I told you that I need to find that two person are selected from first five from 5%. So the word says selected. Okay. Now I'll teach you arrangement and selection. Before going to selection, I'll be teaching you the arrangement. Yes. In arrangement, let's take an example that total three persons are there. Let's take three students are there. Now I want to arrange those three students or arrange two students in a bench. I want to arrange two students in a bench on a bench. You can say no need to go on the grammatical part. Total three students are there. I need to arrange them in a bench. How many total number of ways that I can arrange those three students? Okay, let's name those three students as ABC. Now, what are the possible ways that I could arrange them? I can make them sit like AB, A on the left side, B on the right side. I can make them sit like BA. Okay, on bench there are two seats, AB. Then I can change them to BA. I can make them sit like BC. Total there are three students. I have to only pick up two students and make them sit on the bench. So I can select B and C also. Now if I just shuffle them, that means B on that side, C on that side. It's fine, I can do that. So it's CB. And I can do this way also. AC and CC. So there are six ways that I can arrange two students from three students. Okay, there are six ways. Now same example we are keeping in the selection. Okay, same example. Total there are three students. We are arranging two students, but here it is not an arrangement. Here it is selection. So we are selecting two students. When I select two students, it's not like selecting on a bench. It's like I am selecting two students for cricket. Yes, when there is a selection, obviously purpose changes. In arrangement, you have to make them sit In selection you are selecting for some purpose, you can say. So here you are selecting two students for playing cricket. Okay, which are these two students? These two students, which are these three students? These three students are ABC. Okay, now just visualize that there are three students in your class. I am selecting two students for cricket. Okay, I am teacher and I am selecting two students. Yes, what are the total possibilities? If I call two students from the three students sitting in the first bench, I'll call for the cricket that Mr. A, please come, Mr. B, please come, and I am taking them to the cricket match or the cricket match. Yes, so I have selected A and B, and A and B have gone to play the cricket. Now just imagine that if I select B and B and A would go to play the cricket, would it make any difference? You are getting my point. Would it make any difference? Obviously no. A and B and A both are same for selection purpose. They, if you will call A and B, those two students will play the cricket. If you are, if you will tell B and A, those two students will only go for the cricket. There is no difference by calling A B or B A. Both are same. If you call A B, it's fine. If you call B A, it's fine. So what my point is that when you are selecting A, B and B A both are same, you will be not writing the second time. If you have written A B, done. B A you will not write. Yes, but if I call A and C, this is different. Now two students, other students are gone. B is not there, so A C is different. Now I will not write C A obviously. Okay, here it was CA in this question. There's a bit typing mistake. Now I'll not write CA here. Okay. Then I'll call for B and C. Yes, these are also two students. So if you will monitor, if you will monitor, then you can see that if I have selected two students from three students, there are only three kind of possibilities. Only three kind of possibilities if I am selecting two students from three students. Okay, so you can see the basic difference between arrangement and selection. Okay, these topics you have learned in the standard 11th. These topics are known as permutation. These topics are known as permutation. So arrangement was known as permutation and selection was known as combination. Selection was known as combination. Yes, these two topics we have learned. So this is the basic difference. When just you have to simply learn and remember what is the concept. When I talk about arrangement, ABBA both are there. If I tell you about combination, then ABBA are not there. Only AB is there or BA is there. They both are one in selection, that is in combination. Okay, yes. This permutation and combination you don't remember, and I could make you remember also what was there. I could tell you this array. This permutation was like this: N P R. For example, there are three students, and R is two. You have to arrange two students, so you have to solve like this. It's 3 into 2, 6. So you can see there are six possibilities here. Okay, total six possibilities are here. 1, 2, 3, 4, 5, 6. Combination was NCR. Yeah, this I am writing to calculate that you can know that there are only three possibilities. It is NCR. NCR is like 3C2. That means you are selecting two students from three students. So it's 3C2. How would I solve this combination? I would solve this like this: 3 into 2 upon 2 into 1. So 2 cut 3. So you can see 1, 2, and 3 possibilities are there. So this is permutation and this is combination. This is permutation and this is combination. Yes. Okay. Now jump to that second question. A balanced dice with third question. Two persons are selected from five person A, B, C, D, E. 2 persons are selected from five persons A, B, C, D, E. As I told you, that when I'll select, I'll be writing like this. Yes, so 2 persons are selected from five person A, B, C, D. Now, as I told you that as this is selection, how would I selecting? I'll be selecting A and B. What I'll be doing? I'll be selecting A and B. Now, I'll not be turning it reverse. B A is not for me because I am selecting it. Now you got my point. Yes. In selection, you will be writing A B. B A will not write obviously. Then we'll be writing A C. Then I'll be writing A D. Then I'll be writing A E. Yes, so A B A C A D A. No reverse, huh? No B A, no C A, no D A, no A. Only one side. Now, now I can select B and C, but as I told you, I'll not be selecting CB. Okay, if I've selected B and C, it's good. Then I can select B and D. Then I can select B and E. Okay, B C B D B E. It is good. Then I can select CD. Then I can select CE. Yes. Then I can select DE. No other combination you can do. There are total 4 and 3, 7, 7 and 2, 9, 9 and 1, 10 combinations. So there are 10 possibilities. Sir, how would we know that there are only 10 possibilities? Okay. Just now I taught you how to calculate it. You have to calculate it like this: NCR. Total there are 5 persons, so n is 5. Total there are 2 selections, so r is 2. Now if you want to solve this 5C2, it's like this: 5 into 4. You have to go on the reverse side, and if r is 2, then only you will keep 2 digits: 5 into 4. Upon, in combination you have to divide. In permutation we don't divide. So it's upon 2 into 1. So 5 fours are 20. 20 upon 2 is 10. Now you can count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. Okay. So these are the 10 possibilities. One more sum we'll be doing of the selection. Selection. Illustration number 4. Yes, what is illustration number 4? Let's read. Write the sample space of random experiment of randomly selecting three numbers from first four natural numbers. So you have to select, just wait. You have to select three natural numbers from first four natural numbers. You have to select three natural numbers from first four natural numbers. Now, what are the first four natural numbers? Obviously, it's 1, 2, 3, 4. And you have to select three from this. Now, how many numbers will be formed? We are finding first how many numbers can be formed. Okay. So, see, as I told you that it is NC4. It is NCR, sorry. Now, N is 4 and R is 3. So, 4C, 3 combinations will be there. It's 4 into 3 into 2. As the R is 3, we will take 3 digits in reverse. 4, 3, 2. Then here it will be 3, 2, 1. So 3, 2, 3, 2 cut. So now it is 4. So total 4 combinations will be there. Now I know that 4 is the answer, but I have to make, obviously I have to prepare or make this 4. How are they? I have to select 3 numbers from 4 numbers. So I can select 1, 2, 3. Now as I told you that when I am in selection, if you have selected 1, 2, 3, that means you will not write 2, 1, 3, you will not write 3, 2, 1, you will not write 3, 1, 2 or nothing. 1, 2, 3 done. But I can write like this 1, 3, 4. Obviously. I can write like this also 1, 2, 4. Okay. And I can write like this also 2, 3, 4. Here you can see there is no shuffling, but there are different combinations only. It's 1, 2, 3, it's 1, 2, 4, it's 1, 3, 4, and it's 2, 3, 4. Okay, so this kind you can do it. So this is the basic selection which I was teaching. We are doing a fifth sum of 1.1. Write the sample space for the experiment of randomly selecting three numbers from first five natural numbers. You have to write the sample space for selecting three natural numbers from first five natural numbers. So this is exercise 1.1 fifth. What you have to do? Select three numbers from five natural numbers. So what are these five numbers? It's 1, 2, 3, 4, 5. And you will be selecting this 1, 2, 3, 4, 5. Yes. As I told you, how many numbers would be there? You can find it first. There is calculation NCR. So if I want to select 3 from 5 digits, the calculation will be like this. It's 5 into 4 into 3 upon. 3 into 2. Okay, so 3 cut, 2 twos are 4, so it's 5 into 2, total 10 combinations. So total 10 combinations will be there. So u is equal to 1 2 3. It's 1 2 4, 1 2 5. Okay, then it's 1 3 4, 1 3 5, then it's 1 4 5. You have to make your mind work like that, that it thinks all the combinations. If I have taken 1 2 3, then as I told you, there cannot be 3 2 1, there cannot be 2 1 3. It's like you have to go straight 1 2 3, then you can go 1 2 4, then you can go 1 2 5. Now 1 2 was a constant in first line, that I changed the second digit, I took it 1 3, so it's 1 3 4, then 1 3 5. Now 3 was a constant, I changed it that 3, now it's 1 4 5. Okay, see now. Now I'll take now I'll skip that 1. I'll take with 2. Now it's 2 3 4. Let's keep 2 and 3 constant. It's 2 3 5. Now change that 3. Make it 2 4 5. Okay. Now skip that 2. You can do 3 4 5. Yes. And as I told you that you cannot make more than what I told you. If 5C3 is 10, then I guarantee you that only 10 combinations will be there. You can see on the screen 3, 3, 3 and 10. Yes, there cannot be 11. You can freely, whatever time you take, you can find. If you find 11th one in this, then I'll make write your name in the book. Okay, instead of any other author. There can be this much only combinations. Yes. Okay. Uh, then so we have done first sum, we have done fifth sum. Let us do second sum. Write the sample space for the marks scored by a student appearing for an examination of 100 marks and the number of sample points in it. So you want to give the number of sample points also. So this is exercise 1.1, sum number 2. What is question? That a student is appearing for an examination of 100 marks and you have to write the sample space of marks, and they told you that you have to write integer. That means you don't have to write marks like 10.5, integers. Okay, so how many marks he can have if there is examination of 100 marks in your school? How many marks you can get or a student can get? If there is an examination of 100 marks, a student can get 0 also. See, we are finding sample space, so we have to write all the possibilities. 0 can, yes, 1 2 3 4, 100 marks paper is that, so he can get either 0, he can get either 1, he can get either 2 3 4, and he can get up to 100 marks. He can get up to 100 marks. Now they ask you that write number of sample points. Sample points, that means you have to find the elements. Number of sample points. How many elements are there? 0, 1, 2, 3, 4, 5, 6, 7, and 100. So 1 to 100 are 100 digits, and 0 is the next one. So there are total 101 sample points in the above question. Yes. So we have done quite many sums. As I told you that you have to write all the sums with me in your rough book, and I'll be telling you about the instructions of fair book in the lecture only itself. Uh, Now we'll continue further in your next lecture. Till then, you can subscribe this channel and you can watch all the previous lecture. We have completed full part one of your standard. Thank you.